Okay, today we are going to look at 2-3 graphing rational functions. So we're going to take what we did in the past two lessons, looking at graphs and identifying key features, and looking at equations to find our key features, putting that together, and then actually graphing it ourselves. So today, by the end of the lesson, your goal is to be able to graph rational functions. So to graph rational functions, we need to identify vertical and horizontal asymptotes, graph them using a dotted line, identify any holes, put those on the graph, and then we're going to use our graphing calculator to identify integral points on each part of our graph using our table and our general shape, and then plotting that on a graph. And remember, the graph is always going to approach those asymptotes but never actually reach them. Before we get into our first example, just a reminder, we're going to need our graphing calculators today, so you're going to want to have those handy. And to graph, you need to hit the y equals button and type in your equation. Y equals button is right up here. And then we're definitely going to be using that table today. So to get to the table on your calculator, remember, we're going to hit second, which is that blue button there, graph. Because right above graph in blue, it says table. So that's why it corresponds with that second blue button. So example number 1 says graph f of x equals x minus 1 divided by x squared plus 4x minus 5. So as we talked about before, anytime we're given a rational, we want to make sure we factor the numerator and the denominator before we do anything else moving forward. Luckily, the top is already factored for us, so we just have to take a look at the bottom. So the top is going to stay x minus 1. And in the denominator, we want to factor. We're going to use the AM method, and we're going to think what adds to 4 and multiplies to negative 5. And those two factors are going to be x plus 5 and x minus 1. Because if we think 5 minus 1 is going to give us 4, but 5 times negative 1 is going to give us that negative 5. So going down our checklist, the first thing we're going to look for is any holes. So we should recognize right away that our x minus 1s are going to cancel, which means we're going to have a hole at x equals 1. Now we need to figure out what our y coordinate is going to be. So in order to do that, I'm going to rewrite our simplified rational. And our simplified rational is going to be 1 over x plus 5. So we have 1 over x plus 5, so to figure out our y coordinate, we're going to take our 1, our x value, and plug that in. So if our input is going to be 1, we have 1 over 1 plus 5, which simplifies down to 1/6. So our hole is going to be at 1/6. All right, next we're going to look at our vertical asymptote. And our vertical asymptote, remember, comes from what's left over in the denominator. So that means our vertical asymptote is going to be at x equals negative 5. Because if we set that equal to 0 and solve, that's where the negative comes from. And our horizontal asymptote, I like to go back and look at our original function. In our original function, we have our degrees being small over large. So we have an asymptote at y equals 0. Remember, slow. So our horizontal asymptote is going to be at y equals 0. And for our 0 or x-intercept, we have nothing left in the numerator after our hole cancels. So we're not going to have any 0 or x-intercepts. So we have none there. So let's go ahead and plot our key features on our graph. So when we're graphing our vertical asymptote, we want to go to negative 5 and we want to draw a vertical dashed or dotted line. Remember our arrows because that is continuing on forever. And our horizontal asymptote is going to be a horizontal line at y equals 0, also including those arrows there. Then we have a hole at 1/6. So at 1, roughly 1/6, I'm going to draw a hole there. Remember, the graph is not going to go through that point. Now that we have these key points, we need to figure out what are some points on this graph and where are the pieces of our graph. So in order to do that, looking for a general shape, we're going to plug this into our calculator. So go ahead and take your calculator out and plug in our function. So after we plug in our equation, so remember in y equals, we want to make sure to put things in parentheses. So we have x minus 1 up here in parentheses divided by, in parentheses, x squared plus 4x minus 5. Then we hit graph, and we can see here on this graph our general shape. We can see where our x and y equals lines are, which are asymptotes. We can see that it's approaching that line x equals -5 and y equals 0. So we're going to use this general shape in a minute, but first we want to take a look at our table. So we want to hit second graph, and it's going to bring up our table. So we can see our table here has a bunch of different values. We have our x values and our y values. You can see at -5 here, we have an error, and at 1, we have an error. And that's because that's where our vertical asymptote and our hole are. And remember, we don't have any points there. So there is no output, there is no y, so we have an error. So we want to determine a couple points on both pieces of the graph. So we can see that we're going to have part of our graph up here, and we're going to have part of our graph down here. So that's going to be on the left side and the right side of our vertical asymptote. So we're going to try and find some integral points, some points that work out nicely. We want at least one on each piece. So looking at our table here, this is going to be our vertical asymptote. So we want a couple points on one side and a couple points on the other. At least one that works out nicely. So if we're going to pick some points, on the left side we have -6, -1, and on the right side we have -4, 1. We could pick some ones that have those half points like -3, 1/2 and -7, 1/2 to give us a little bit more of an accurate graph, but we're looking for at least one integral point on each side. So we want to plot these points. So I'm going to plot my point at -6, -1, and I'm going to plot a point at -4, 1. Now if I go back and I look at my graph, so if I hit that graph button, I can see here what my general shape is. So my general shape is going to go up here, it's going to go up towards my vertical asymptote, and go down here, it's going to go down to my hole. Remember, there's no point there, and then it's going to continue on after it. We're getting really close to both of these asymptotes, but remember, never touch it, never cross it. It's a boundary. So then down here, by this point, we're going to go down towards -infinity, and then over towards -infinity that way. So this would be graphing our rational function, identifying all the key features, putting them on our graph, and then looking at our general shape and some integral points on both pieces of our graph.